Alright, I am getting ready for today's vlog, and I'm going to say something I've always wanted to say. I'm about to turn left at Saturn. Hello friends, and welcome to Escaping the Mouse with your host, me, Breck Roll. Alright, we are in Houston, Texas, and today we are going to visit the Johnson Space Center. I've wanted to do this for a long time. Basically about 30 years ago, in one of the jobs I had, I ended up spending one summer in Huntsville, Alabama. And Huntsville, Alabama had a pretty impressive space center, and I went and visited it. Obviously that was way before I was vlogging, way before the internet, and I've always wanted to come visit Johnson Space Center in Houston and ultimately Cape Canaveral in Florida. Well, we are at Johnson Space Center today. We're going to probably spend a couple days here looking at some of there's different tours, different things to see. It's a great museum, and I'm looking forward to seeing this. And yes, that is the Space Shuttle Independence on the back of a 747. This is the second space shuttle I've seen. I went with Jordan to see another one of the space shuttles. I think it was Endeavour in Los Angeles, but this is the first time I've ever actually seen one on the back of a 747. How awesome is that? And that's just the beginning. We aren't even inside yet. Alright, we are inside. Wow, there's a lot of stuff here. Look at that model over there of the space station. How awesome is that? And of course you can't have any kind of a museum here without a big, massive gift shop at the end. So we'll have to check that out at some point. Let's just start looking at some of these exhibits. So this part of the exhibit talks about the solar cells that power the entire station. Basically, when unfurled, this solar panel covers almost an acre of territory and has over 500,000 individual solar cells. Generates between 96 and 110 kilowatts of power. They say that's basically enough to power 56 homes. And one of the problems they have to run into with this is there's an enormous amount of heat. You wouldn't think about that, but a lot of heat is generated because you're up above the atmosphere and all that, and you have to get rid of that heat somewhere. Now we need some heat in order to keep the astronauts inside safe, but what they have is actually liquid ammonia running through the system to keep everything cool, and then all of that is vented out into space so it doesn't overheat. Alright, that's the International Space Station, and you can see some of those solar cells on either side of the station. So yeah, this is a partnership between the United States and the European Space Agency and Russia and Japan. They all kind of contributed to this, and this thing is flying in orbit right now. In fact, oftentimes it passes over the Earth, and you can actually see it from Earth. I've seen it a number of times. There's apps and websites that you can go to that will tell you when it's going to be passing over a certain area in your near you, where you can look up and see it. But it's really quite an impressive sight to see. Check it out if you ever get a chance. Alright, so this exhibit here actually shows the 7 astronauts that are currently on board the International Space Station right now. Looks like it's just a temporary exhibit so they can swap out the different ones as different astronauts go on board. It's kind of cool. They got this big, about 20-foot diameter model of the moon with all the craters and all that up here. Very interesting. How often do you get to get this close to the moon, right? Crazy. In case you ever wondered what the dark side of the moon looks like, that's it. I've heard rumors that if this side of the moon had been facing the Earth, that big giant crater in the middle would very likely have changed religion on Earth, because we would have looked at it as a big giant eye looking down on us from space. Fortunately, it's the other side that faces us. This is actually one of the rocket engines that NASA has used for 30 years to lift astronauts and the space shuttle into orbit. It's a very reliable basically reusable rocket engine that they refurbish after each use, and then will reuse it again. Just for the record, that thing's probably about 14, 15 feet tall. Now this is kind of interesting. This is the biological isolation suit that Michael Collins wore once he returned from the moon. You see, they were concerned that that the astronauts might bring back spaceborne illnesses with them, so they made him stay in a isolation suit for a period of time after he returned to Earth, just to make sure he didn't get infected with anything and all that. This isn't to protect him in space. This was to protect us from space. So this is the in-flight suit that Wally Schirra wore when he orbited the Earth in 1967 on the Apollo 7 mission. So this is a Mark III spacesuit. This is, I think, what most people think of when they think of spacesuits, is something like this. Now, these hard suits had an advantage. Prior to the hard suits, the astronauts, if they were going to do a spacewalk, they had to do what they called pre-breathing, where they would breathe pure oxygen for several hours in order to get all the nitrogen out of their bloodstream, so that when they go into space, they don't experience the space version of nitrogen narcosis, which is, we call that the bends. When you go deep diving and you come back up too quickly, the same thing happens when you go from a normal atmosphere to a zero atmosphere, to a vacuum, is you can form nitrogen bubbles in your bloodstream, which can kill you if it gets serious enough. These hard suits prevented the need for the pre-breathing and made it easier to get out of the shuttle or the rocket in a pinch if needed, because there was less time, because you just wear this the whole time. All right, now this is this typical lift rocket that NASA uses. The center thing is liquid filled, and like the space shuttle, the outside pieces are solid rocket boosters, which are used to lift the thing off the ground, and then they're jettisoned about halfway up, usually a minute and a half into the launch. Just to give you a perspective of how big this thing is, it's probably 50 feet to the top there. This is just a scale model. This isn't even the real thing. And that is an astronaut right there, just to kind of show you the scale that we're talking about. Yeah, this thing is massive. This thing's massive by itself, but the real thing is even bigger. And for the record, that little bit part on the top there, that's where the astronauts sit. Yeah, it's like sitting on the top of a big giant bottle rocket. Now this is kind of interesting here. This is talking about the immense distances between Earth and Mars. If you were to have a communication with somebody on Mars, they would, depending on where the planets are relative to each other, it would take between 3 and 20 minutes for something you to say to get to them, and then another 3 to 20 minutes for the message to get back. Yeah, not exactly live communicating, right? But that's how far it is. You know, Mars, when it's furthest away, it's 20 light minutes away, and so radio signals only travel at the speed of light. All right, this little section here talks about what you have to do on Mars in order to feed the astronauts, because you can't just bring the food with you. You have to have the ability to grow it there. And so they talk about how they do that, and they have special plants and special LED lights that are designed to help the plants grow, and they can raise the height of them as the crops get bigger. And that will be a key thing to surviving on Mars, is being able to grow enough food in order to sustain themselves. And so any Mars mission is going to have a section where they can grow their own food, and this is sort of what that looks like, or what that will look like. In fact, I guess apparently they're thinking about using Martian soil, so they don't have to haul that with them. I don't know, we'll see if that works. So this is basically a map of the planet Mars, and showing where all the different landers and rovers and things like that have been placed. There's the Curiosity and Spirit rovers, the Viking 2 lander, Opportunity rover, Sojourner, Viking 1 lander. It's funny, Olympus Mons, sometimes called Mount Olympus. I actually tried to stump one of my college geology professors once. We were talking about volcanoes, and I asked him, so what kind of a volcano is Mount Olympus on Mars? Unfortunately, he knew the answer. Alright, so this is kind of cool. This is talking about from time to time an impact will happen on Mars. It will blow debris off the planet and it will eventually resettle on Earth. And this is apparently the only piece of Mars that they found that the public can actually touch. So I'm actually touching a piece of Mars right now. How cool is that? I'm guessing that won't be in the gift shop. This little section deals with some of the mystique revolving around the planet Mars and some of the movies that have come out. I'm surprised they don't have something for Mars Attacks on here, because they do have more recent movies like that one. But then they have like the original War of the Worlds and Invader from Mars. And should have worn my alien t-shirt from Baker, California, right? Would have fit right in. Now that's a model of the lunar lander that landed on Mars during the Apollo missions. Obviously it isn't the real thing, because the real thing is still on the moon, or at least parts of it. You can even see the astronaut the window up there. Okay, this is cool. This is the world's largest oriented meteorite. Now, basically an oriented meteorite, a normal meteorite, when it re-enters the atmosphere, it tends to tumble. But some meteorites, basically, they fall into orbit, and basically the same edge is on the leading edge all the way down. And so what you end up with is kind of a smooth surface on the top, and then kind of a convex concave shape on the bottom here where there was less heat. And this is sort of important because learning how to make this happen is also important on figuring out how to make re-entry vehicles not tumble when they come through space, because that's the basic thing. You don't want, when you got your astronauts in a re-entry vehicle, you don't want them tumbling and being thrown around inside the capsule when they come down. You want it coming in with one side facing the atmosphere and one side facing away. And the study of these oriented meteorites help us make that happen. And yes, you can play Angry Birds at the Space Center. Alright, this is kind of cool. This is a simulator that they use to train the astronauts how to operate the lunar module when it comes to landing. That is pretty cool. In case you ever wondered what the inside of that thing looked like, it sort of looks like this. Alright, this is kind of cool. Apparently on the first couple shuttle missions, when they were still testing everything to see if everything worked, the first pilot and co-pilot were actually seated with these ejection seats. So in the event that something happened, the pilots could eject out of the shuttle if they were at low enough of an altitude. Yeah, that's got to be scary enough doing that for real in a jet plane, but imagine doing that out of the shuttle. Apparently after about the fourth mission, they declared that the shuttles were suitable for use, and they removed these. So here we have a scaled model of the Space Shuttle Endeavour attached to the external fuel tank and solid rocket boosters. This is the shuttle that I saw in Los Angeles with Jordan. I mean, obviously this is a model of it, but it was the Endeavour that we saw. The real one is much bigger and wouldn't fit in this room. Well, this is pretty cool. This is a 1/20th scale space shuttle model that they used for wind tunnel tests. Got to see how the thing performs aerodynamically. Okay, this thing is pretty cool. You may remember back in the 70s, they put up the first space station called Skylab, and it re-entered, kind of came out of orbit and crashed into Australia in the late 70s. But they got a model of it here, and they've got this little demonstration here that shows how they got astronauts into it. Basically, this was the module that would carry the astronauts, and when the time came to link up, they had to make this piece fit into that piece so that they could get the module to link up. And so imagine you're flying at 150,000 miles an hour, or chasing this thing in orbit, and you got to fit that peg into that hole in order to make the thing work. Apparently we can go into this thing, so I'll go check that out in a few. So that's the inside of this little module that links up with the Skylab. So I guess your astronauts would have been sitting there. Actually, looks like I'm upside down. It would probably be more like that, because you can see kind of the headrests here, and all the controls are here. And this is sort of a display of some of the things that you don't think about so much when you think about space travel, and that is like personal hygiene. So apparently every astronaut that went into space was given a little hygiene kit that had deodorant, and I see soap, and that's dental floss down there, and a little tube of chapstick. Gotta look your best when you're in space. Oh yeah, and some of the food that you can get came in all dehydrated little packages here. That's that right there is broccoli au gratin, rice pilaf, fettuccine. Doesn't really look like fettuccine, does it? And cauliflower with cheese. Yum yum. Just makes your mouth water to look at it, doesn't it? So this is a list of some of the checklists for STS-43 on different things. Entry checklist over here, contingency deorbit prep, system data malfunction. Basically a bunch of lists of things of what you do if something happens. Alright, as promised, we are going to walk through the training module for Skylab. Now, I've seen this before, this white thing going around. Since you're in zero gravity here, this is something that they use to allow the astronauts to get exercise, because they could just run around that like a big giant hamster wheel. Scary, huh? Think you could do that? And of course they got a guy up here that's spinning, showing the effects of zero gravity. When you're dealing with zero gravity, you have to deal with the fact that, if you don't hold on to something, you'll just float away. So they got like foot restraints up here. You can put your feet in that and kind of stay in one place. And of course, you don't have to have everything on the floor. You can do anything anywhere you want, because it's zero gravity, right? In case you ever wondered how they shower, yeah, now you know. Basically, you just clamp that whole thing closed and do your thing. Oh, there's an exercise bike too. Oh, and there's where you sleep. It's almost like sleeping in a coffin. But you got to worry about that too. If you're in zero gravity, you'll just float away. Alright, this section deals with the Apollo-Soyuz missions, which in the early 70s were testing cooperation between Russia and the United States. Things were a little uneasy in those days. But they tried to reach out and, in science and do their thing. Look at that tape recorder. Early Walkman. An Omega watch with the hand still attached. And a Snoopy cap. It's funny, I was looking at this. My dad had this exact calculator when in the 70s. It's kind of funny that that was the one they had in space. Alright, this is the Apollo-Soyuz docking module. Basically, it's a trainer. It isn't the real thing, but it's the real size, and it actually isn't very big. This whole thing side to side is probably only 10 feet long. But you know, this is how you docked up with the module here. In fact, you can show in here. You can see just how big it really is. It really doesn't hold a whole lot of people. Okay, so this is kind of cool. This is an Apollo era command module fuel cell. Basically, what it did is it used hydrogen and oxygen to create fuel, and then the byproduct was water, which the astronauts themselves could actually drink. And there were several of them on board the lander modules, and that's how they got their electricity. Plumbing in and out, electricity in and out. How cool is that? Alright, so this is one of the control modules that they used in Johnson Space Center to manage the flights and the Apollo missions, and even into the 80s when they had the space shuttle. Real primitive looking, isn't it? I bet you my laptop has more processing capability than this does. Heck, my cell phone probably does. Alright, we're getting back to talking about the moon now. These are some of the elements that they found on the moon. That is actually lunar soil right there. And then they've broken up and given it examples of some of the different minerals that they found. Pyrozine, ilmenite, plagioclase. Alright, sorry, I had problems saying that in geology class too. Olivine, aluminum, calcium, titanium, magnesium, iron, silicon. Basically, that's a chart there that shows the various components that made up the moon. So these are some of the rock samples that were brought back from the moon from different Apollo missions. Those two from Apollo 15. That one from 16 and that one from 17. Kind of studying the geology of the moon kind of helps us understand how it formed and its connection to the Earth. Okay, this is kind of interesting. This kind of talks about how you store lunar samples on the moon, because in the moon there's no water, on the moon there's no oxygen, and so if you expose these rocks to the kind of stuff that we have on Earth, the water and the oxygen, some of these iron samples will start to rust, and that's not a good thing. So when they store them in a nitrogen-rich environment to inhibit them and keep them as pure as possible. Alright, so this display shows some of the different scientific research that was done and some of the tools that they had available to them on the Apollo missions. And so, you know, they're got them drilling for samples underneath the surface of the moon. Notice that they each have like cameras on them. That's how we have some of the footage of of some of the live video footage from the moon. And of course they planted a flag on the moon, and they're mentioning that they had to have like a horizontal piece across the top there to make the flag extend outwards. Otherwise it would just drape because there's no wind and no nothing on the moon to make it blow. And that's kind of a cool lunar vehicle that they had that they used to drive around on the moon's surface with. Obviously not the original one. The original one is still there. That's kind of cool. That's the docking hatch from the Apollo 17 mission that separated the service module from the lunar module. See, when it went up there, it looked like this. That's the service module, and that's the lunar module there. And in order to get from one to the other, they had to open up this docking hatch to get in. How cool is that? Let's take a look at that from both sides. You see, both of the modules had to be pressurized for air, and so you had to be able to, go from one to the other, and this was the hatch that made it possible. How awesome is that? That thing's been to space. Apollo 17. Alright, this is pretty cool too. This is the Apollo 17 command module. This is the part that came back to Earth after the final moon mission and brought the astronauts safely back to Earth. You can see one of them in there. Obviously it's a dummy, not the real one, but you get the idea. And there's seats for 2 more. And look at this door. I'm going to take a kind of a walk around this thing. Like I said, this thing went through re-entry and ended up back in the ocean, which is where they picked it up. Remember when I was talking about a little earlier about the meteorites that basically stayed facing one way and didn't tumble? You know, that led to the creation of items like this, because this thing here, the bottom end, ended up being the side that faced the Earth when it came in, so it got all the heat and all from re-entry. And you can see when you get close to it that a lot of the debris got kind of burned off. They call it ablative armor, because what it does is the second it gets so hot that it separates, it basically flies off and removes all the heat from the module, so that the module doesn't burn up. We learned the hard way what happened on that shuttle mission when Columbia re-entered, and it lost one of its heat shields and basically burned up on the way in. And these are a couple of examples of the Omega moon watches. See, when you're wearing a watch in space, you can't just wear a regular watch, because regular watches aren't going to deal with the temperature or the pressure or the lack of oxygen or shock or acceleration, all that fun stuff. And so these watches were designed to deal with that. Pretty sharp looking timepiece, right? This is kind of cool. This is a model of Explorer 1, the first artificial satellite launched by the United States in 1958. Like I said, it's life-size, so that's 3 of its Wernher von Braun. Okay, that's Wernher von Braun is the father of American space travel. He was also the guy that invented the VX rockets for the Nazis. But after World War II, he came to the United States and became part of the early NASA program. It's funny, he was once said that when they first tested the VX rocket, he said the rocket performed flawlessly. It just landed on the wrong planet. All right, this is a replica of Phase 7. It was a Mercury 9 spacecraft that Gordon Cooper orbited the Earth in 1963. At the time, he was the man that spent more time in space than anyone else. He orbited the Earth 22 times over a little bit more than 34 hours. Very cool. You can kind of see him inside there too. Yeah, not a lot of leg room in there. I probably wouldn't do well. Actually, we're going to flip this thing around here so you can even see it in the proper orientation, because that's his knees and his hands that you can see there. All right, this is pretty cool. This is one of the first rockets ever created by a guy named Robert Goddard. You've heard of the Goddard Space Center? Yeah, it's named for this guy. And basically, in 1926, he flew the first rocket. It went 41 feet in altitude, 184 feet total, and traveled a total of about 60 miles an hour. How cool is that? Liquid-fueled rocket. You really can't see it that well, but the lighting is a little extreme here. But that is pretty cool. All right, this is cool. This is one of the orbiter access arms. It's actually a real one, and this is the one that the astronauts used aboard the Space Shuttle Challenger before it exploded. It was the first time it had ever been used. You know, this is basically what happens is this allows the astronauts to get aboard the craft and get in there. Now the arm itself remains attached to the orbiter until about 7 minutes before launch. So in an emergency, the astronauts can get out. But in an emergency, even when it's retracted, it can be moved back into place in about 15 seconds. Now, it starts on this end. They start off in a white room, which is basically kind of a controlled environment where they can hold 6 people at a time. And it was used to help the astronauts get into their suits and get ready for the trip to space. We're going to walk through this here in a minute here, because this is one of those things that you can get access to. So let's take a walk through this thing. Alright, so this is what the astronauts would have seen. This is the inside of the white room. And like I said before, this is where they help the astronauts get into their suits before they cross the gangplank over to the orbiter itself. And like I said, the first time this was used was with the Space Shuttle Challenger before it exploded on takeoff, and it was used again on the first time back into space after they kind of reworked things and figured out what happened and tried to figure out how to prevent that from happening again. And then, of course, this was the walk to the orbiter. Yeah, you know I gotta do this. They're allowing people to walk through both the 747 and get up there. I don't know if you can actually get into the shuttle, but at least get up there and look at it. So you know I gotta do that. But I see people going in over here and coming out over there. So that's gotta be fascinating. We gotta check that out. Let's go in. Okay, so this isn't quite as luxury oriented as you think as a typical 747. No seats, no nothing, like that. But this thing was not designed for comfort. It was designed to serve a purpose, and that purpose was to transport the shuttle, which was manufactured in California, to Cape Canaveral in Florida. Alright, this is sort of at the front of the craft, and you wouldn't think about it, but when you put a 165,000 pound space shuttle on the back of a 747, you gotta have a little stability, and they put dead weights on the plane to balance it out so it could fly. That's kind of cool, huh? And there were a couple of seats on board, not a whole lot, but just enough. So this was actually a radio-controlled test model that they used to verify that this would actually work.
And yes, we can actually use the Boeing 747.
And there's actually some footage of the original.
To do the approach and landing test, the first gliding flights of the space shuttle, to prove that whole concept.
Successful flights with models led to
That's kind of cool. So they actually used, when they flew it the first time, they used the 747 model to actually verify the thing could land, because they could do their aerodynamics tests with the shuttle on top of the 747. All right, so this was the power distribution panel that basically sent the power all over the ship to make sure that all over the accelerometers and all the test equipment had all the power they needed. And this is basically the airplane after it was built, and they basically stripped out all the stuff inside of it to get rid of any of the weight that they needed. Actually added some bulkhead fortification to make it strong enough to hold the shuttle on the top. And in fact, you can see a lot of that here. That isn't typical for a normal 747 because it doesn't have to be that strong on top. But when you're holding a 165,000 pound shuttle, you kind of have to do that. Oh, here's an example here. It shows what happened if you try and do one that's reinforced versus not reinforced. This is without the reinforcement. And look, you can kind of see how the hull of the airplane kind of buckles a little bit under the weight. Whereas this one here has a reinforcement to support the weight. You notice that the hull doesn't buckle as much under the weight of the shuttle. Yeah, so you can see there's more of the reinforcement they built into the plane to strengthen the hull. Okay, so this is a simulated wind tunnel here to simulate how the space shuttle and the 747 will behave under certain conditions. If you add the weight, the airplane dives down. You remove the weight, the nose goes up. You can increase the air pressure, and the goal is to get it just to the right level where we're just in that little sweet spot where everything turns green there, and that's ideal for the plane and the shuttle. So this model here shows how they install the shuttle on top of the 747. I got this big rig here that holds the shuttle up. They drive the airplane underneath it and then lower the shuttle onto the back. Gotta get it centered just right. So now you can see there's a line going up to look at the orbiter, and I'm not going to make you sit through that, but you'll get the benefit of seeing what's in there. And in case you ever wondered what the inside of a jet engine looks like on a 747, now you know. It's interesting looking at the underside of the orbiter, and you can see all the individual heat shields. Word is that every one of those heat shields is unique and of a unique shape and consistency. And so if you lose one, you can't just go to a box, get another one. You have to get the exact one to fit in that spot. That's what all the numbers are that you see on there, are the numbers of the individual heat shield tile. Remember that a couple of those were damaged when Columbia went up and a piece of the solid rocket booster came off and damaged the heat shield, and that was what caused the Columbia to be lost on re-entry. Is a couple of the heat shields were damaged, and it allowed the heat from the from re-entry to enter the orbiter, and that's all she wrote. Okay, this is kind of cool. You actually get to go on the shuttle. I don't know if any other places allow you to do this. These are, I guess, secured lockers for each of the crew members. Some of their space suits, launch and entry suits. I guess once they're up, they can go more casual. But when you're going up, when you're coming down, you gotta be prepared for whatever might happen. I guess they brought CDs up with them here too. I'd have too much fun in being in orbit playing with zero gravity. Oh, there's a spacewalking suit. How cool is that? You can go outside and that's what you wear. Is that the way in? I guess that's the way in. Because I guess you go up to the top. So you go in, you get into here, they suck the air out of there, and then you go up through the roof, I guess. How cool is that? This is another shot of this. I gotta admit, I'm not entirely sure how they get out. It doesn't look like the door opens up on top, so there's got to be some sort of way to get out. Yeah, I don't know. It's one of those questions that best left unanswered, I guess. Okay, we're about to go into the cargo hold. Actually, I'm in the cargo hold right now, but this is actual footage of them opening the doors and launching whatever it is they're going to launch. I bet you that's how this works. I bet you they enter the airlock from the other side, and then the only way in and out is when they open the lids on the top, and so the airlock is locked between the cabin in the front and this area in the back. I bet you that's how they get out. See, now they got the doors open. This is obviously Discovery. And they use the arm to move the cargo out. Even though it's zero gravity in space, it's still very heavy to move. And you have to be very careful because you don't want to bump against the side of either the orbiter or the cargo. And then this is some of the different crews. That's a Challenger up there with its crew. They were lost in their mission. Look at the doors on the top there. Those are the things that open up and allow whatever the cargo is to get out. And there's the robot arm right there too. So that is what helps. See, it's just sitting on that little platform there. They got a camera on top of it. And I guess that's a simulated cargo there. That's them loading something else using the arm, of course, the arm right there. Wow, how cool is this? I don't know of very many other exhibits where you can actually walk aboard the shuttle. Hey, can you say you've been aboard a space shuttle? I didn't think so. Normal everyday garden pruning shears, they modified for space travel. They had to remove the antenna before they could pull it back into the shuttle payload cargo area. That's a trip. All right, we're now on the flight deck here, and this is actually some of the panels that are on here. And inside the actual cockpit here, how awesome is that? It's like a very elaborate kind of computer game, right? And it's all above us too here. They got the windows kind of blocked out. I think probably keeps the light under control under here so you can get better video footage. I appreciate that. Of course, we got the nice overlook view of the cargo hold here too. You saw that a few minutes ago, so a little closer to the robot arm that loads and unloads everything. Very, very cool, huh? And of course, there's the outside from the front here. You see all these little holes in the side. Those are booster rockets for maneuvering the shuttle around. So if you need to make it go backwards, you'll fire those. If you need to make it flip one direction, you'll fire those. If you want it to flip the other side, you flip the other side. That's pretty cool. How close do you get this? How often do you get this close to a space shuttle? Close enough that you can actually touch it. Just makes history real, right? Another close-up of the orbiter from the front here. Remember how I told you that the heat panels are each one of a kind? They all have a number on them. So you can tell which number you got to replace. They're all unique. And I think they're discouraging people from touching it from this position because they got all these panels in the way, but fortunately I'm tall and have long arms. I can actually still reach it. Okay, I gotta admit, all the way through this thing, I was wondering how they got this thing into its place. It's not like there's just a runway that you can land on this facility here, but Apparently what they did is they took the wings off of it, they unloaded the orbiter from the airplane, took part of the airplane apart, and brought it through the streets of Houston. Look, there's a mate trying to make a turn here and get it around the corner. It comes, I think that's the tail wing. That's amazing. Like I said, I was wondering how they got that in here.
Very much so.
And then they used a crane to load the orbiter back on top. How cool is that? And this is one of SpaceX Falcon 9 rockets that they've got on the property here. These are pretty cool too. Now, one of the major innovations that came with this rocket is that this first stage can be reused. Usually when you launch a rocket back in the Apollo days or even in the space shuttle days, everything used to get the rocket off the ground for the most part was almost lost. Now that changed a little bit with the shuttles because they got to the point where they could recover the external tank and I think even the solid rocket boosters. But this first stage of the Falcon 9 rocket was actually capable of landing, and so they could bring it back and land it upright, which was really, really cool. That was a major innovation. And then of course they deploy these little flaps on the way down in order to help control the descent and slow it down so that it can land safely. And the major innovation were these things here in the back, because these extend outwards and turn into the legs that allow the rocket to land safely and be reused. This one's pretty weathered, so I gotta wonder maybe if this one's actually been used and isn't being used anymore. And I'm guessing they call it the Falcon 9 because it's got 9 rocket boosters on it. So I think we're coming to the end of this video. I hope you enjoyed this. I got a big kick out of seeing this stuff. Come back next time because we are going to take a couple of tours through the facility and see some more fun stuff. So I think that's all I have for today. Thank you as always for watching, and I'll see you next time on Escaping the Mouse. Good night.